To begin with today, I want you to expand the following 4 sets of brackets. So just pause the video and expand the brackets. So what should you have got? Anything to the power of 0 is 1. Anything to the power of 1 doesn't change. Your squared would have been a double bracket expansion, and your cubed you would have had to do a triple bracket expansion. If I'd have asked you to expand 1 plus x to the 4, it's starting to get a bit long and take quite a long time. You would have had to expand it 2 brackets with 1 plus 2x plus x squared in. So what we want is to be able to see a pattern and a way of doing this without doing the full expansion. So what we can see here, you should be able to see they all start with 1 and the powers of x increase. We also have a pattern in the coefficients, and actually the coefficients, the numbers in front of the letters, follow the rows of Pascal's triangle. So if I just bring Pascal's triangle up here, so Pascal's triangle is created by starting row 0 with a 1. That's my 1 that I get on 1 plus x to the 0. So row 1, which corresponds to my power of 1. Here I've got coefficients of 1 and 1. With my squared, that matches row 2. My coefficients match 1, 2, 1. Okay, row 3, that matches my power of 3. I've got coefficients 1, 3, 3, 1. So if I want to expand 1 plus x to the 4, I can get my coefficients from row 4 and just increase powers of x. So I'd have 1 plus 4x plus 6, x squared plus 4, x cubed plus x to the 4. So a much quicker way of expanding. So again, similarly, we could go all the way up and we could expand 1 plus x to the 6. So this time we've got a power of 6 here, so we're going to need to add row 6 to Pascal's triangle. So we create new rows on Pascal's triangle by starting at a 1 and then just adding the 2 numbers above. So I'll get 6, 15, 20, 15, 6 and 1. That's going to give me my coefficients, and then I'm just going to increase my powers of x. We don't always have a 1 as the first term in the brackets and then a plus a letter. We could have 2 letters, but the principle is going to be the same. Power of 0 just going to equal to 1. Again, a plus b to the 1 is just a plus b, so the coefficients 1 and 1 follow row 1 of Pascal's triangle. When we get a plus b squared, we can see we've got the coefficients again from Pascal's triangle, 1, 2, 1. The second letter, the b term, just like the x, is increasing in powers, and we can see here the a, the first letter in the brackets, starts at the highest power, which is my squared from here, and then it decreases in powers. A plus b all cubed. Again, the coefficients from Pascal's triangles, the b increases in power, the a increases in power. The b increases in power, the a decreases in power. So what are we actually doing here is something called a binomial expansion. A binomial expression has 2 terms in it, and a binomial expansion is when we expand a binomial expression. So put the title in your books, binomial expansion, and if you've managed to print the note sheet, you can grab that now. We're going to write on it and have a go at expanding a plus b to the 5. So our power is 5, so we want row 5 of Pascal's triangle for our coefficients. So we're going to start with the first letter in the bracket. It's got a coefficient of 1, and it starts with the highest power of 5. Then we're going to move to the coefficient of 5. The a power is going to go down by 1, and we're going to increase the b powers by 1. Coefficient of 10, a powers down by 1, b's up by 1. Another coefficient of 10, a powers decreasing, b powers increasing, and so on, until we get to the final term. We've got a coefficient of 1, the a's I've gone down to a to the power 0, which is just 1, and so we just get b to the 5 on the end. So you might just want to make a note on here that these powers the a powers reduced by 1, and my b powers increased by 1. Right, let's go through this example here now. So now we've got a 2x at the front of our brackets and just a number 3 at the second term of the brackets, but we've got a minus in the middle that we need to take care of as well. So first thing to spot is that we've got a power of 4. So if we went back to Pascal's triangle, we'd see that our row 4 was 1, 4, 6, 4, 1. So that's going to give me my coefficients. Now, because we've got a bit of working out to do here, the way that I want you to write this out is, to begin with, as we work out each term, we're going to work down the page, and then we'll put all the terms together across the page for the full expansion at the end. So I've got my row 4 of Pascal's triangle, and I'm going to start by writing that. Change to the red pen, writing down the side of the page. So I've got 1, 4, leave a bit of a gap between, 6, 4, 1. Okay, so that comes from my power of 4 is my 4th row of Pascal's triangle. So then, if we think about the pattern we had before, we take the first term in the brackets, so that's 2x, and it starts off at its highest power, which is 4. And the reason I've put the 2x in brackets is because we need to remember that the 2 is raised to the power of 4 as well as the x. And then we can work that out. That gives me 16x to the 4. We move on to the second term, my 2x, I reduce the power by 1, and now I introduce my second term in the bracket, but I need to remember it's minus 3. So this is where we need a bit of space for working out. So I've got 4 times 2x cubed is 8x cubed times minus 3. And if we work that out, we get minus 96x cubed. Moving on to the third term, my 2x, decrease the power by 1, minus 3, increase the power by 1. Okay, important to put the minus 3 in brackets because we all know that minus 3 squared is plus 9. So when we work this one out, we're going to get 216x squared. The next term in my expansion, 2x reduce the power by 1, minus 3 increase the power by 1. So that's 4 times 2x times minus 27. That gives minus 216x. My last term, the 2x's have been reduced to power 0, so that's just 1, and minus 3 is up to the power of 4, so that gives me 81. And then what we can do at the end, once we've done all our workings out down the page, is write out our expansion, 2x minus 3 to the power of 4 equals, and string it all back together. For our final answer. Right, what I'd like you to do now is pause the video and have a go at this one. Okay, when we get higher powers, so you notice you've got a higher power of 5 here, sometimes it doesn't want you to work out all the terms, this just wants the first 4 terms in ascending powers of x, but simplify each term. Okay, so pause the video and have a go at this. Right, if you've had a go at this one, this should be your workings. Working out each term down the page. Notice that I've only done the first 4 terms. This here is the 5th row of Pascal's triangle. And when we string it all together, you should end up with 32 minus 240x plus 720x squared minus 1080x cubed. And here we can put ... on the end because we haven't done all the terms in the expansion. Right, we're going to try one more now together. This time we're going to just want to work out one of the coefficients. So we don't want to do the whole expansion. Sometimes you're just asked to work out one term or the coefficients of one term. So here we can see that we've got a power of 6, so we want row 6 of Pascal's triangle. So I find that up to row 5 is quite easy to remember, and then it's quite quick just to work them out from there. So I've written out row 5, and then I've just added up to get my row 6. Now, so that I get the right term, what I like to do here is I'm going to write down my rows of Pascal's triangle down the page again to start off my workings out. So I've got 1, 6, 15, 20, 15, and we'll see if that's far enough. So there's my row of Pascal's triangle. And now I'm going to write down kind of my workings for each one. So we start off with, we've got the first term 5x, and that's going to be to the power of 6. Then here we've got, going to have 5x, reduce the power by 1, and then introduce the a. Now the next one would be 5x to the 4, and I'd get a squared, and then I'd get 5x to the 5 and a cubed. Now if I want the coefficient of the x to the 4 term, I can see that that is going to come from this working out here. So actually I'm going to stop there, and I'm not going to work the others out, and I'm just going to work out this one. So that's going to give me 15, and then we're going to work out 5x to the power of 4. So 5 to the power of 4 is 625. X to the 4 times a squared. So my coefficient of the x to the 4 term, if I do 625 times by 15, I get 9,375. A squared is my coefficient of my x to the 4 term. Right, what I'd like you to have a go at now is you're in your AQA Further Maths textbook, which a scan of this exercise is in Files on Teams in the Binomial Expansion folder. I want you to try these questions, some of question 1, some of question 2 in 3 to 8, and then if you have any time, which you may or may not do, there's some Corbett Maths questions on Binomial Expansion, and I want you to do 13 to 16. I've also put these into the Files folder on Teams.